Ah, buenos días a todos y a todas, bienvenidos a esta fantástica sesión de física, las grandes ideas que cambiaron el mundo. Desde este momento voy a hacer el cambio a inglés debido a a nuestro invitado, que es un gran invitado. So, welcome to everybody. Thank you very much for being here in this weekly meeting of physics to write these ideas that changed the world. This is a regular class of Universidad Nacional de Colombia, of the campus Bogota of the Faculty of Science. And I am very delighted today because today we are having a really special guest. Is Professor Nidhal Gersum. He's an Algerian astrophysicist. He got his master's degree and his PhD from University of California in San Diego. He also has some postdoctoral research at NASA Goddard Space Flight Center. And since 2000, he is at American University of Sharjah in the United Arab Emirates. But he has a splendid, really splendid CV. I like it very much. But above all, he's a fantastic person who has been working a lot in how important is the Islam for the modern science. This is something that for me has been a recent discovery. I will say no more than 5 years ago, I got the fantastic surprise to understand how important the Islamic world is for the modern physics, for the modern science. And also I discovered that Professor Nidhal is one of the persons in the world that has been working a lot trying to diffuse all that knowledge to the rest of the world. He has several books. He is very active in the social media. I don't know how many followers do you have, Nidhal, in Twitter. I wish I had 1% of the followers you have, but it's just fantastic the work that you are doing. And before to start, let me tell you that here in Colombia, we Universidad Nacional de Colombia is the most important university of Colombia. It's one of the top 10 universities in Latin America. And also it's a, let's say, scientific driving university. As a university, was founded in some secular values, and it has been also very fantastic because it has allowed us to really interact with different type of religion and different point of view of science. And I will also tell you that this part, the part of how important is the Islam in the formation of modern science, is a part that is very important for the first part of this course. I have several guests along the course, but so far you are the most important guest that we have had until now. So I am very happy you are here, Nidhal. Thank you very much for coming.
Good morning to all of you on the other side of the world, and maybe good afternoon, good evening, perhaps in this eastern part of the world, maybe Asia, perhaps some people are joining also from Europe and Africa. As I said offline to Dr. Diego Alejandro Torres Galindo, I am extremely delighted to be part of this because this is the first time I actually give a lecture in all of Latin America. I visited Brazil several years ago, only for less than a week, but that's my only direct interaction with South America or even Latin America. So I am absolutely delighted to be invited to do this. Secondly, I am also very delighted to see that you address big questions of history or big topics, big ideas in history. I am an astronomer and a physicist. I'm an astrophysicist, but I consider the history of science and the philosophy of science as an absolutely integral part of the quest of knowledge to understand what we have done, what we have learned, who contributed what, not to assign credit, but to really build the history of ideas. I tell my students, you do not understand an idea really unless you understand why it was introduced and when it was introduced, after what, and then you can only build a map of knowledge. And so this is extremely important. I will be giving you a talk which I hope will not be too long, maybe 45 minutes or so. And my goal is really just to highlight a little bit the trajectory of science in the Islamic civilization from the early 9th century to almost the 18th century. Not to do a chronology, but again, to do a map of the main ideas, why it prospered, how it prospered, and then how it declined. I consider the question of decline as absolutely fundamental and important, because we want to avoid all these downward trajectories that happen in civilizations, have happened at least in the past. We don't want science to suffer declines, even though, of course, the conditions for modern science today are very different from the conditions of science several centuries ago. For all these ideas, I'm really happy to be doing this, and I really look forward to the discussion, because I want to hear what kind of questions people are asking. When I teach, one of the joys of teaching is to hear the questions of the students. So you present something and then you receive a question from a different angle, from a different perspective, something you had not thought about perhaps before, or some idea that needs to be clarified further. Anyway, without further ado, may I start presenting?
Please, and I only know one word that I like very much. Salam alaikum.
Alaikum salam. Salam alaikum means peace on you or peace upon you. This is the greeting. This is just like saying hello, good morning, Allah, etc. This is the same, but the greeting in the Arab Islamic world is salam alaikum, meaning peace to you. So, and it serves, of course, in morning, afternoon, evening, weekend, weekdays. So it's a very good phrase to know and to pass on to others.
Okay. Okay. Salam alaikum and welcome.
Alaikum salam. So let me start sharing my screen.
Okay, it's okay. We are seeing it.
You can see. Okay, very good. I want to start by telling you that about 10 years ago, there was a renewed interest in so-called Islamic science, or as I put Islamic science in between quotes because it doesn't mean that the science is Islamic. Science, of course, is not supposed to have an identity. It's supposed to be universal. It doesn't depend whether you are Islamic or Hindu or Christian or secular or whatever. But the phrase among historians refer to Islamic science, meaning the science that was practiced during the Islamic civilization. So this is just a contraction of science in the Islamic civilization. People say Islamic science. So about 10 years ago, there was a new interest. All of a sudden, people started to become more interested in what happened, what kind of science emerged and got developed during that Islamic civilization from the 8th, 9th century to the decline, which we'll talk about the decline later, maybe the 16th, 17th, 18th century. Roughly, people talk about roughly 1,000 years. There was this big exhibition in England, in Britain, started in Manchester and then made the rounds of many cities around the world, called 1001 Inventions, Discover the Golden Age of Muslim Civilization. So this was a big exhibition that started in England, as I said, and then moved on. There were books that got published, including the book that accompanied the 1001 Inventions. And there was this short movie with this famous actor, I'm sure many of you will recognize, Sir Ben Kingsley, in the form, it was like a 15-minute, 20-minute little movie in the form of Harry Potter, resembling Harry Potter, these young kids who discover one sort of secret place which has some old science and wonderful. It's a little bit magic and it's a little bit history and a little bit of science. So there was this big renewed interest with, as I said, many books. There were TV series, which I'll mention in a moment, numerous articles. There were controversy around this. Is this really true? Is this exaggerated? So this was about 10 years ago when all of this began. At about the same time, in January 2009, there was a 3-hour BBC TV series titled Science and Islam, presented by Jim Al-Khalili. Jim Al-Khalili, maybe some of you know, has a number of books on science and history of science, is a physicist of Iraqi ancestry. His father was Iraqi, his mother was British, and I think they immigrated to Britain, and he's still, of course, alive and kicking, is in good health, has a very good career in England as a physicist, but he started to present these ideas about what happened during that Arab Islamic civilization. So he said, and I want to quote him, he said, Isaac Newton is the undisputed father of modern optics. Because as you know, Newton realized that white light is a collection of all the colored wavelengths and invented the reflecting telescope and so on. But Jim Al-Khalili says, or so we are told at school, this is what we learn. We learn that Isaac Newton was the father of modern optics. And yet, he says, in the field of optics, Newton himself stood on the shoulders of a giant who lived 700 years earlier. He meant Ibn al-Haytham. And he goes on to say, without doubt, another great physicist who is worthy of ranking up alongside Newton, Al-Hasan ibn al-Haytham, who lived between Iraq and Egypt in the late 10th century, early 11th century. Ibn al-Haytham is regarded as the father of the modern scientific method. Most people in the West will never have even heard of him. So you can see these new sort of surprising facts and ideas were being presented to the Western audience. Why did science take off in the early Islamic era? There are two big theories, and I'm just going sort of touch on ideas here and there. As I said, I want to sort of do a map of ideas. There are two theories as to why did science prosper in the Islamic era, in the Islamic civilization. One says Islam, by its own activity and what it asks the Muslim follower to do on a daily basis, weekly basis, yearly basis, requires some scientific knowledge. For example, everybody knows that Muslims pray 5 times a day at specific times during the day. So this is sort of a picture of a mosque or a minaret on a mosque. Here's a diagram of the position of Mecca, and most people know that Muslims, wherever they are on earth, when they pray, are supposed to stand up and direct themselves to the direction of Mecca. So they are supposed to know where is the direction of Mecca from any position. And this requires calculations because this is spherical trigonometry. You need to calculate depending on latitudes. You need to calculate when is the sun going to rise and when is the sun going to set and what time is it going to be the middle of the day and so on. And then there was the month of Ramadan. Most people are familiar with the month of Ramadan. This is the 9th month of the lunar calendar when Muslims are supposed to fast during the day and only eat and drink during the night. And so you have to calculate, because this is a lunar calendar, you have to calculate when does this 9th month, the lunar calendar, the lunar year is shorter than the solar year by about 11 days. And so this requires some calculations as to when are we going to see this new crescent, which tells us that the new month is going to start. Then there are some other activities in the Islamic religion itself, such as things related to money, inheritance, alms, commerce, medicine, architecture, things that are allowed or not allowed, or you have to do it this way or that way. And all of that required some science, a lot of mathematics, algebra, trigonometry, astronomy, for all kinds of activities. The second theory says, no, it was not for practical reasons that science developed and flourished. It was because knowledge in general is glorified in Islam. There are hundreds of verses in the Quran that talk about the importance of knowledge, the status and place of scholars in society and in the eyes of God. So for example, I want to mention a few quotes from great thinkers and scientists of the Islamic era. Al-Kindi, largely regarded as the first philosopher of Islam, said, "Our goal must be to garner the truth from wherever it may come, for nothing is of higher importance to the seeker of truth than truth." So you can see sort of the objectives and the main principles at play. This is a stamp showing Al-Kindi from Syria. Many people know Avicenna. Avicenna was a great philosopher. He is more famous among the general public as a great physician, a doctor, a medical doctor, but he was a great physician and he was a polymath, a Renaissance man, so to speak. He mastered a number of topics. And so Avicenna said, for example, "He who gets used to believing without proof has slipped out of his natural humanness." And Al-Biruni here on the right, standing up and sort of, these are paintings, of course, we don't have real images of any of these people, but Al-Biruni also largely considered one of the greatest physicists and astronomers of that time, geologist, historian, philosopher, one of the greatest minds of the entire history of humanity, and I'm not exaggerating. Al-Biruni adopted induction, which is sort of bottom-up methodology, as the valid approach for research, and debated it with Ibn Sina. Ibn Sina was a philosopher and was a deductionist. He would start with principles and then extract some ideas or results from the big principles that he would set. And all of this happened 2 or 3 centuries before Bacon, who is very often credited as being the father of the scientific method. The other important thing to know about the Islamic civilization is that there were some important institutions of knowledge or science. Now, there is a reason why I put knowledge/science. The first reason is the word for science in Arabic and Islam is the same as the word for knowledge. We don't have 2 different words. Now people, of course, have introduced synonyms, new words, but originally the word ilm, I-L-M, ilm, is the word that represents all of that knowledge because it has an integrated meaning. So knowledge, science, philosophy, etc., all of that is one word. In any case, there were a number of institutions where people were practicing this search and quest for knowledge and science. Let me start with some of them that that are not directly related to science, are not institutions of science, before I get to the institutions of science. One of them is madrasas. The word madrasa and the idea of madrasa has become very famous in the last 10 years or 20 years, and perhaps with bad connotations, with a bad meaning, because people associate the word madrasa as a religious school or school of religious learning, and people have associated it with fundamentalism and people who preach anti-modernist ideas and things like that. But in the old days, in the old centuries, a madrasa, which simply means school, that's the word in Arabic. Madrasa just means school, school of anything. In fact, the primary school that we as children go to here are called madrasa to this day, even though it's not about religious learning or religious law. But in the old days, a madrasa was a school of religious law. Now you may think, what does this have to do with science? In general, there was no teaching of real science, to be honest, but the teaching of religious law required some knowledge and competence in mathematics and astronomy, and sometimes in other fields such as medicine and so forth. Why? Because, as I said, there were a number of things, activities in the Islamic religion itself. So somebody who goes to an Islamic scholar and says, I want to know how to distribute my money among my children after I die, or what to do. Is this allowed or not allowed? If I exchange or give or take or do commerce in this manner or that manner, then this Islamic scholar who is trained in religious law must understand a little bit of mathematics, a little bit of astronomy, a little bit of medicine in order to answer such questions and queries. So that's where the madrasa required some knowledge and perhaps some development of some scientific information. Two, there were a number of universities going back to the 9th century, the Nizamiya and Mustansiriya in Iraq, in Baghdad, because you may know that Baghdad was perhaps one of the greatest centers of learning. Al-Azhar in Egypt still exists today, and the Egyptians are very proud to repeat that Al-Azhar is a university that goes back more than 1,000 years, and sometimes they say it is the oldest university that still exists. There are two others, Qayrawan in Tunis, Fez in Morocco, Damascus. All of these had universities, not in the modern definition of a university, but a place where you would find many scholars, people who had a lot of knowledge, and students would come to them from different parts of the Islamic world and spend their months and years, and in the end get a certificate. So every teacher, every professor had the right to give a certificate to whoever student has reached the required knowledge. And once they have collected a number of certificates, then the students sort of graduate and leave. There is this famous House of Wisdom. There are a number of books titled The House of Wisdom. There is more than one House of Wisdom. The most famous one is the one in Baghdad. These houses of wisdom are sort of great centers of learning. Sometimes they are described as research centers. Sometimes they are described as great libraries. Sometimes they are described as places of learning and teaching, these houses of wisdom. But not because I am an astrophysicist, but because truly what I consider one of the greatest contributions of the Islamic civilization was observatories. Now, you have to remember and keep in mind that all of this is before the invention of the telescope. So most of these observatories, and I'll show you some images and diagrams of them, are pre-telescope observatories. But they are extremely important because they allowed for astronomy to really develop a lot. There are some paintings, of course, we don't have real images from those times, but this represents sort of a place where a number of scientists are present in the same building, in the same place, and doing observations with these tubes. These tubes don't contain lenses or mirrors as telescopes do, but they are just to sort of point toward the direction, and you can see some arcs here under the tubes, which are meant to allow you to measure angles of elevation and so on. So these were great observatories. The very first one was the one that was built in Baghdad in the year 827. So this is early 9th century, just 1 or 2 years after the translation of the Almagest. The Almagest is one of the greatest books of astronomy written by Ptolemy in the 2nd century AD in Egypt, in Alexandria. Ptolemy was a Greek, an Egyptian Greek in Alexandria, wrote this big book, which became the reference, was translated very early on in the Islamic civilization, and then become the basis of development of astronomy. But few survived intact when rulers changed. The problem with these institutions is whenever one new ruler replaces another by death or by military coup or whatever, then the whole outlook changes. So maybe the new ruler doesn't like this kind of science, doesn't like this kind of spending on knowledge. And so these institutions would stop functioning or would be destroyed. Sometimes they get more funding. So it was really dependent on who was in charge. Let me give you a few more examples of important observatories in the Islamic civilization. One of the greatest ones was the Maragha Observatory, which in that time was part of the region called Azerbaijan. Nowadays it is in northwestern Iran, was founded in 1259, hosted some very surprising advancements in Ptolemaic astronomy. Tusi, one of the greatest astronomers of that time, did his work there, was the director of the observatory and worked there for about 30 years. This is what remains of it. These are real images from today of what was then this great Maraga observatory. This is a drawing of how it looked. Another big one was in Samarkand in Uzbekistan, was founded in the 15th centuries. You can see this continued for centuries from the 9th century to the 13th century, 15th century. Ali Kusji was also a great 15th century astronomer, this is one of the scientists who studied the work of Ali Kusji, wrote that Ali Kusji said, since neither observation nor mathematics proves the contrary, the rotation of Earth must remain a possibility. This is to indicate that these ideas of is the Earth rotating around itself and is it moving in space, these ideas which preceded what Copernicus introduced, there is no doubt, of course, that Copernicus was a true revolution. The Copernican revolution is agreed upon by everybody. But even before, and of course, you know that Copernicus published his book in 1543. So this is in the mid 16th century, and this is in the 15th century. So in the century preceding it, there's a lot of discussion and a lot of science pertaining to does the Earth rotate and does it move, and what kind of a system should we be constructing. Finally, there's the Istanbul Observatory, here represented in this famous painting. The Istanbul Observatory was built in 1577, so this is late 16th century, but unfortunately was destroyed 3 years later because the new ruler was convinced that this is no good. Some paintings showing the activities. This on the left is supposed to represent the Istanbul Observatory. The Istanbul Observatory had 15 full-time astronomers working there as researchers being paid by the government. And on the right, you can see a number of scientists using different tools, including a celestial sphere and things like that. Some more images or some more diagrams. This is from a wonderful book, the Book of Constellations by a Sufi, known in Latin or in the Western world as Azofi. A Sufi lived in what is now Iran and produced this extraordinary book, which had beautiful drawings. In this case, you see this is the constellation of Gemini or Gemini, and on the right, data and information about what was known at that time about these constellations and stars. Maybe you ask, what about women? And indeed, to be honest, there were very few of them. Very few women are known to have participated and contributed, perhaps because history did not record their participation, perhaps because society did not give them much of a chance. But there is a handful of women who became famous, are known in history to have contributed. One of them is this Fatima of Madrid, who was the daughter of Maslama of Madrid. Maslama al-Majriti, in Arabic, al-Majriti meaning of Madrid. And his daughter, Fatima, is known to have participated. This page I took from a calendar that the International Astronomical Union published in the year 2009. The year 2009 is very, very famous and very important because it's the year, it was the 400th anniversary of the invention of the telescope, 2009, 1609, 2009. And so in 2009, the International Astronomical Union decided to publish a calendar, 12 months. For each month, they selected one important astronomical personality from history, from all of history. And so they put some big scientists such as Copernicus and so on, but they selected, it was interesting that among all the Islamic civilization people who contributed, and I have already mentioned a number of names, they decided to select Fatima. Fatima was known, you can read perhaps the text here, or I can send it to you, was sort of her father's assistant. Her father was also known to be a great scientist in Spain of the time, Al-Andalus, and she participated with him. And we know that after he passed away, after he died, she made corrections and continued the work. So she published certain tables and data and observations. You see her here holding an astrolabe and making some observations and recording. Of course, all of this is imagined and drawing, but we know for sure that she published additional data and made corrections to what was done before. So this is just one example. She wrote several works which are known as corrections from Fatima. With her father, edited and corrected the astronomical tables of Al-Khwarizmi. Al-Khwarizmi, big mathematician and astronomer from Iraq, 9th century, is the sort of the big developer, if not the inventor of algebra. They also worked on calendars, calculations of the true positions of the sun, the moon, and the planets, tables of sines and tangents, spherical astronomy, astrological tables, parallax calculations, eclipses, and moon visibility. All of this is in the text that was published on this page. I forget which month they gave to Fatima in that calendar that the International Astronomical Union published in 2009. Now, after all this, and this is really brief and sort of brushing quickly on what was the situation then, there is this sort of statement or sentence called known as curators of the Museum of Greek Science. There are some people who think that what the Islamic civilization did essentially was take what the Greeks did, translate it and preserve it and pass it on to the West after all of that was translated into Latin and passed on to Europe. And then in Europe, people like Copernicus, Galileo, Kepler, and later Newton really developed the science. But the statement or the claim is the Islamic civilization did not contribute anything meaningful. All they did was take all of that knowledge from the Greeks, preserve it, translate it to Arabic, and then translate it to Latin, or have others translate it to Latin, and that was it. I want to show you very quickly in one slide a number of contributions and achievements in the Islamic civilization. They developed algebra, because I think we cannot say invented algebra, although this is very often claimed. Algebra did exist previously, but Al-Khwarizmi, whom I mentioned earlier, really made huge developments to the science of algebra. It was interesting, I want to say here, just in between parentheses, that Al-Khwarizmi, when he published his work on algebra, the famous book of algebra, he clearly stated in the introduction that this is a new tool, that this is a new approach, a new way of solving problems. And he listed a number of problems, some of them having to do with everyday life, like commerce and so on, and some of them even having to do with the religious activity of the Muslims. Revolutionized optics. I'll show you this in a minute. Optics was absolutely revolutionized during that time. Constructed sophisticated astronomical instruments, sundials to measure the time of the day, armillary sphere, astrolabes, quadrants, all of these are for measurements. Developed trigonometry, both plane, flat trigonometry and spherical trigonometry, synthesizing the Greek chord with the Indian sign. So one of the good things that the Islamic civilization did was it took science from wherever it came. A lot of it came from India, actually, not just all the Greek, Egyptian, the pharaonic knowledge, the Babylonian past knowledge, and integrated it and synthesized it, corrected it, and presented it in new approaches. Extended number theory to include irrational numbers, solved higher than quadratic equations, cubic equations, fourth degree equations were solved sometimes graphically, sometimes with new approximate methods. Developed the ideas of John Philoponus on the impetus theory, an alternative to Aristotle's natural motion. I just want to show one slide on the optics that Ibn al-Haytham, you remember at the beginning I quoted Jim al-Khalili, who said Ibn al-Haytham should really rank on the same level as Newton, at least in terms of what he contributed in optics. what people have referred to as a mathematical theory of vision. So he not only explained how light travels, how it travels in air, how it travels in glass, how it travels in water, in anything that is transparent, how it reaches the eye, how it goes into the eye, and how we see, how we form an image in the eye. All of that was developed. I am here quoting, but I don't have time to read all these quotes about what Ibn al-Haytham contributed in terms of optics, experimental investigations of the behavior of light, inventive geometrical proofs, and constant forays into the psychology of visual perception. So all kinds of diagrams, except for this very last one. All of these are original diagrams from the famous Book of Optics. He had a book of several volumes called the Book of Optics that Ibn al-Haytham published in the late 10th, early 11th century between Iraq and Egypt. He's also the inventor of the famous camera obscura. The camera obscura is sort of this dark little place where if you go in and you make a little pinhole, then you can form an image at the back from the light coming into that little hole. The image will be inverted, but it is the way for you to see what is happening in a dark environment. And people consider it as the precursor, sort of the first idea behind the camera. Of course, today the camera, the light goes through the lens and the little pupil, and then we form an image either on a film or on a CCD wafer or something like that. But then Islamic science, this Islamic science declined. So when did it decline, first of all? This is still a big, debate about this. There's historians discussing the decline of the Islamic civilization, not only the civilization, but the Islamic science. It is usually said that the decline had occurred by the 13th century when Baghdad was sacked by the Mongols led by Hulagu. But this is problematic because Hulagu, even though he sacked Baghdad and destroyed the House of Wisdom and all of that, he immediately after that built the famous Maragha observatory that I told you about. And there was also the building of the Istanbul observatory, not by Hulagu, but by others. So at least astronomy, we know for sure, continued at least until the 16th century. So we can't really say that the decline occurred in the 13th century. What I would say in a minute, sort of the conclusion is, we cannot give a date or a period for the decline of the entire science because different branches of science continued to flourish or declined at different centuries. Arabic science, at least medicine. So we know at least medicine continued to remain active into the 18th century. And meaningful, we know also that meaningful exchanges between European and Ottoman scientists, the Ottoman civilization continued until the early 20th century, continued up through the generation of Newton. At least into the late 17th century, there were these exchanges between scientists in the Ottoman world, meaning the Turkish world, Istanbul, and so on, and the Western world. What were the causes of the decline whenever that occurred, whether it occurred mainly in the 12th, 13th century or 16th century or 18th century? What were the reasons for the decline? There's a complex set, and here I'm really sort of just giving you a few flashes, and I'm happy to discuss all of this later. First of all, there were some socio-political reasons for the decline. The support and the development of science in that civilization was too strongly tied to the ruler or rulers. And because there was political instability, there were internal factional upheaval, there were fights within the Islamic empire, so to speak. There was fragmentation, there were break apart, and there were external threats from Christendom and the Mongols. Of course, there were crusades, and there was the invasion from the Mongols from the east. All of this disrupted the work. So obviously, political, historical, sociological reasons affected the development and in some cases led to the decline of science. There was little institutional development. We did not develop, for example, societies of knowledge, such as the Royal Society or Academies of Science, institutional support, organizing, how things are published and distributed. All of that is lacking, and that's one of the failures of the Islamic civilization, that it did not develop the framework and the institutional support that would help the scientists contribute and work together. And very often, these scientists, the Muslim scientists, worked in isolation, again, because of the political fragmentation, the geographic spread. You have to remember that the Islamic Empire spread from all the way from Spain, or at least Morocco, all the way to the east in India and China. And there was no internet at that time, and so that it was very difficult to exchange publications and achievements or new ideas, new calculations, new measurements, new data. And so that led to, if in a corner you don't have new ideas and new data coming to you, then of course you're not going to develop very much. Another important reason for the decline is simply the rise of Europe. In Europe, starting from the 10th, 11th century, we started to witness the emergence of universities, real important universities, which were independent, which had their own curriculum, and so on. The universities of, for example, in Italy, Bologna and Padova, in France, Paris, Montpellier, in England, Oxford and Cambridge, in Scotland, Edinburgh, and so forth. All of these were real new institutions that established a new kind of learning and a new approach, a new type of development of knowledge, and within that knowledge, science. There was this critical approach now to dissecting what the predecessors did, from Aristotle to the Arabs. And so that was a turning point and led to the rise of Europe, which quickly left the Islamic world behind. There was also, of course, the invention of the printing press by Gutenberg, and that led to this very fast dissemination of knowledge and information, and that led to a quick development of knowledge and science in Europe, contrary to what was still happening in the Arab Islamic world. And then there was the age of discovery and prosperity, the big trips to the Americas, of course, the discovery of the Americas, and of course that's a double-edged sword. I don't have to tell you, you know this much better than me, but that was, had its benefits and drawbacks. It had, in some ways, it was a big disaster, but in some ways, this money that was taken from the Americas, which was used for greater prosperity in Europe, helped fund the development of science. And then there was the religious objections in the Islamic world. We cannot ignore this. Some Muslim scholars were not embracing of all the sciences. There were debates as to what was acceptable and what was not acceptable. Some of them rejected some ideas from cosmology, for example, and some of them did not allow some developments in medicine and so on due to religious ideas. So all of these are sort of a bunch of causes of the decline that I wanted to just present to you in passing. Let me come to my summary and conclusion. As I said, this is just a very broad and brief, superficial overview. I started by talking about the renewed interest in the history of Arabic Islamic science, sometimes referred to as Arab Islamic, Arabic Islamic, Islamic, Arabic. Arabic was the language, so 98%, I would say, of everything that was produced in all those centuries was produced in Arabic, whether the scientists were Arabs or not, and many of them were not Arabs. In fact, the Arabs were a minority of all those scientists, but everybody used Arabic as the language of science at that time. Just like today, we use English almost for all the exchanges and communication about science, the publications and so on. Islamic, because it was the Islamic world, all of that Islamic empire, even though many people who contributed to this science and civilization were not Muslims. So you had people who were not Arabs, many people who were not Arabs, some people were Muslims, or majority were Muslims, some people were not Muslim. And so overall, that whole civilization is very often referred to as Arabic, Islamic, whatever. I talked to you a little bit very briefly about the impetus, what were the driving forces that led to the development of science. So I mentioned some applications in the Islamic life itself, in Muslim life, in religious life, such as prayers and fasting, the month of fasting, the direction of prayer, the distribution of money, inheritance laws, all of that required some development of mathematics, astronomy, medicine sometimes, and so on. And the other idea that really helped develop or push for the development of knowledge and science was this glorification of knowledge. In the Islamic culture, until today, the learned people, the scholars, are considered as the highest level of society. In fact, I like to quote, I should have maybe included this, when there are times of strife and times of terrorism and so on, I tell people, do you know that in the Islamic culture, the ink, there is this famous statement, the ink of the scholar, the ink with which the scholar writes his or her knowledge is more sacred than the blood of the martyr. The people who kill themselves in battle or whatever, even if it is for valid reasons, are less important and less regarded than the scholars, even with their ink. So there is this glorification of knowledge, and I could, talk for a long time about the importance and status of knowledge and science in the Islamic culture and the Islamic civilization. I mentioned sort of in brief, with just some bullet points, some of the important scientific accomplishments which really show that the Islamic civilization or the Muslims were not curators of the Museum of Greek Science. They did not just preserve and pass on. They really synthesized and added and corrected and developed important fields of science. There were some institutions of knowledge or science. I mentioned the madrasas, the universities, the houses of wisdom, the observatories. And I also spent a little bit of time talking about the decline of the Islamic civilization, which is an ongoing debate. Out of all this, from all this presentation, the topic that is still very hot and controversial and lots of writing, and still people publish books on this and discuss it in conferences and lectures, it is the decline of the Islamic civilization and Islamic science. Everybody wants to know, why did it decline? There is sort of a general agreement as to why it flourished, but there is a lot of discussion as to what made it decline. And then there were, of course, some issues of science in Islam, what the religious scholars accept and do not accept. And this is a topic of direct interest and importance to me, because as I teach my science and I do my outreach in science, and I have my YouTube channel, as Dr. Diego mentioned at the beginning, I still today face some resistance by some quarters as to what is, according to them, acceptable and not acceptable, things like the theory of evolution and so on and so forth. So I want to thank you as I close here for your patience. And I just wanted to apologize if I was a little bit too general and too broad and too superficial, but I wanted to keep as much time as possible for the discussion. So I promised myself to keep it under 45 minutes and just to do a really broad general overview, but I am open to discuss any topic in more detail if you wish. Thank you very much.
Thank you very, very much. What a fantastic lecture. Really, really. The first thing that is a really surprise for me is that I always thought that in the Quran was just a simple 2 or 3 phrases talking about the importance of knowledge and the wisdom, but apparently it's not. In the whole book there is a complete set of sentences talking about the importance of to get the knowledge. Is that the way it is?
Actually, it is both. I could have, and I usually when I give this kind of talk to Muslim audiences elsewhere, and I have talk to different people, I show them the statements from the Quran, and I show them the statements from Prophet Muhammad, because to them that is extremely important. If the Quran says this, if the Prophet is saying this, this is to encourage them and to support my drive for science. So I show them the statements from the holy texts. But for an international audience, if your holy book is saying something, then good for you. It's not very important for us. But I wanted to also show here, I wanted to emphasize the main principles that were at play, the principles of rigor, the search for truth, objectivity, induction, deduction, those kinds of sort of big, important methodological principles that help develop the science. In addition, you are absolutely right, in addition to the religious statements that encouraged Muslims to pursue knowledge and science.
Okay, so we have several questions. It's very, very interesting, all of them. But the first one I would like to ask you from Nicolás Rodriguez Mogollón is, how about the relationship, how about the education that we have to give to politicians, and how important is for the current politicians to have knowledge on science?
Yeah, I could not agree more. And this is one of my missions in life. I try to do as much as I can to, of course, educate the politicians and the officials who are in charge of different areas of our lives, because the more they appreciate science, this is very important, the more they appreciate not just the fruits of science, because what we find among politicians, and I think this is true in my part of the world and in the rest of the world, politicians tend to really like products of science, technology, applications. They say, yes, applied, please do applied science. Help us to solve problems of, I don't know, traffic problems or agriculture problems or irrigation problems, water desalination problems. They say, if you can help us, yes, please help us. But that is not sufficient. This is important and good, but this is far from important. What science actually teaches us is a mode of thinking. It is this rigor, this evidence-based. We have to go and check and find out. And we see this even today, internationally with the pandemic, and what are the scientists saying, and how do we prevent the spread of the virus, and how do we prepare or develop vaccines and all of that. So people need to understand how science functions. And I tell people, the more you learn science, the more science you learn, it's not just that you have knowledge and understanding. It is that your mind now will be functioning differently. And we want the officials and the politicians to think objectively, to think in terms of evidence, to apply ideas that we learn from science in all fields, in economics, in education, in everyday life. So it is extremely important indeed to spread this understanding and appreciation of science at all levels, especially at the highest levels.
So there is a huge debate around the world about the relationship between religion and science. Especially here, there is a new, let's say, school that claims that it's better to have totally separated the religion from the science. But in other places, it's not totally clear. What do you think about the current situation, especially because you have been around the world, you have seen both sides, So what do you think about it?
Yeah, that's a very big question, and that warrants, that would need the whole discussion, a whole session perhaps, and maybe some other day, next semester or something, I'll come back and discuss this whole science and religion in the Islamic world and beyond, because as you say, yes, I have participated in various places, and I am very familiar with the debates around the world. But here's the thing. So first of all, it depends on the culture, the societies. Some cultures and societies have established secularism and separation between what we call church and state, or separation of religion from public life. So they say religion should not affect public life, certainly not science, and perhaps not even the fields of education and so on. So that's certain societies and cultures. But certain societies, particularly my society, religion plays a very, very central and important role. And so then it becomes a question of where do you put science and where do you put religion? So for example, I tell people there are topics that should be completely the prerogative of science to address. So if we're talking about, for example, the evolution of organisms, including the evolution of humans, this is clearly a scientific question. We need to go back to fossil record, we need to look at the genetics and so on. This is scientific. You cannot have a religious scholar come and tell me, no, this animal did not evolve, you did not change in the last million years or something. This is not their prerogative, this is not their field of expertise. This is scientific. Now, there are some topics that have to do with how I live my life, my ethics, and what I believe, and so on. That is part of religion, whether I believe, I don't believe, what I believe. This is not for scientists to address and say, you should believe this or you should not believe that. So there are certain areas of human life that are completely for science to address, and the religious people should accept that this is for the scientists to decide and tell us. And there are certain topics that have to do with personal life, belief, ethics, etc., that are not for science to address. Science should not come to people and say, why do you believe in God? There is no God. Why are you believing? Say, that is not your business. You tell me how the universe functions. You tell me how Earth functions. You tell me how humans function, how the human body functions. But you cannot tell me whether there is a God or there isn't a God. So those are sort of the two big separations. But then you get into topics that are sort of in between. So if you come to topics of origins, for example, so we talk about the origin of life, the origin of humans, the origin of the universe itself. So people commonly refer to the creation of the universe. Some others refer to the origin of the universe, the beginning of the universe. And so is there a beginning? Is there creation at the beginning? Were humans created? Or did they just emerge from something? So that's why you get these fields of sort of interaction and sometimes friction between science and religion, because they both want to say something about these topics, usually the topics of origins. So this sort of very, very broadly is the issue of science and religion. And as I said at the beginning, it really depends which culture or society we are talking about. But this is a very, very complex and interesting question to consider.
So it's when did you start this curiosity, or let's say this job of presenting to the world the very important relationship between Arabic Islamic world and modern science and the original science? When was, what triggered that spirit on you?
I always loved the history of science. I am sort of more of a, sort of liberal education type of person. I am someone who believes that education should be broad. I am a proponent of liberal education. And in my mind, these topics are related. So this is why I said at the beginning, history of science, philosophy of science, discoveries, impact of science on society, all of this is very important. And of course, as we just said, the issue of science and religion and so on. So for example, I always wanted to understand, and I mentioned this earlier, I always wanted to understand who discovered what and who introduced which idea in science. So as I'm teaching, I don't know, for example, the Earth is a sphere. There are many people who think that maybe the fact that the Earth is round has only been known for a few centuries. And this is a discovery of modern astronomy. And I tell people, do you know that we have known that the Earth is spherical for several thousand years? And this is important because all of the astronomers of even 1,000 years ago, all of the Arab Muslim astronomers that I mentioned earlier, everybody knew for sure, there was no debate that the Earth is spherical. Everybody knew, and there was no discussion. It was like a given. And yet people to this day, and we have this return of the flat Earth business, to this day, people think that, oh no, this Earth is round is only a new modern astronomy discovery. So to make a long story short, I was always interested in the history of science and the history of ideas and how things relate from one area to another. And when I started to discover some new facts and new ideas that are surprising and interesting and have some impact, I decided that I want to publicize this, to spread this, and not only to my students, but to the general public, to write books. At first, I was writing articles and books, and then YouTube came along, and it became like, if you want to reach people, you better do videos. And so that's how it developed. But at the beginning, it was really this curiosity and interest in a whole constellation of ideas.
So, okay, there is a question here from Miguel Parada. How do you think that the sack of Baghdad affected the decline of the Islamic scientific golden age? And how big was the loss in matter of knowledge, book, scientists that the sack had to the humanity?
Yeah, so that too is a matter for the historians still debating. But what is known for sure is that the sack of Baghdad destroyed all places of learning in Baghdad, including the House of Wisdom. There's this story that there are two big rivers in Baghdad, the Euphrates and I forgot the name of the second one, two big rivers. And the story goes that when all the books that were taken out of these big libraries and houses of wisdom were thrown into the river, these are big rivers, the rivers had black water. The water turned black from the ink of the book. So this just gives you an idea. Secondly, I mentioned that the very first observatory that was built in the Islamic civilization was built in Baghdad or just outside of the city of Baghdad, and that gone, does not exist anymore, has not existed since the sack of Baghdad in the middle of the 13th century. So there is no doubt that, you know, thousands and thousands of manuscripts and books and instruments and places of science were destroyed with the sack of Baghdad. But I also mentioned quickly in passing, if you remember, I said, but only a few years later, Hulagu himself built an observatory, the observatory in Maragha. And so there was destruction here, probably for political reasons and whatever. But at the same time, they had this glorification of knowledge, and they said, I want to build a big science center. So they built another observatory farther out north in what was then Azerbaijan. So yes, the sack of Baghdad was a terrible, terrible event in the history of humanity. But I don't think it sort of broke the science completely, because it continued to flourish elsewhere and developed in other directions.
Okay, I have the last question because we have to go. We have, you know, we are just starting the day here as you are just finishing there. But first of all, before the question, I will really thank you. Really fantastic, fantastic, fantastic lecture. I am so deeply impressed. I'm so happy you accepted, and I will be deeply honored if in the future, in the next year, you also accept to my invitation for a new lecture in this topic. So I hope that will be possible, because I know you are a really, really busy man.
I will be more than happy to. I am glad that you liked the lecture. I was sort of apprehensive. I don't know to what depth or level I should go into, how long. This is in English. I tried to prepare the subtitles as you asked me. I failed because I have never done it before. But in the future, I promise to come back and to do it better with subtitles and everything. And I am extremely happy with this exchange and collaboration.
So I have the last question, and I know that is a difficult one. From all these fantastic achievements, numbers, the measurement of the radius of the Earth, I mean, what do you think is the most important of all of them? I know it's a very difficult one, but from all of this achievement during this golden age, what do you think is the most important contribution to the humankind?
Can I mention two? Do you allow
Yeah,
me to
yeah,
mention
sure,
two?
sure, absolutely.
I think the development of algebra was extremely important because it was a tool that was used in many topics and many applications. So algebra, the development of algebra and the presentation as Al-Khwarizmi introduced it and showed it to people and said, you can use it in commerce, you can use it in your everyday life, in inheritance and this and that. So algebra was very important. But the other one, I think if you ask the historians, they will probably say optics. The development of optics by Ibn al-Haytham, this is not just simple optics. This is optics that does reflection through by curved mirrors, that does refraction, light going through lenses of different shapes, of different material, glass and water. And they had, these sort of big balls of sort of vase which contains water, and they would observe through the vase because it would bring the light more into focus or something like that. So this development of optics, which I think helped, actually definitely helped, because we know, for example, I'll just say this very briefly at the end, Kepler, Johannes Kepler, one of the greatest scientists of the Western scientific revolution, at the same time as Galileo, Kepler, we know for sure that when he was tabulating the data from which he derived his planetary laws, he had to take into account the refraction of light from planets as it goes into the atmosphere of the Earth so when we are seeing the light, we have to remember that this light has bent a little bit because it went into the atmosphere, and take that little bending into account when you tabulate your data, so that when you analyze the data, you're analyzing the real data, not data that has been affected by the refraction of the light that goes through the atmosphere of the Earth. So this just shows you not only the interconnection of all this knowledge, how the East contributed to the West, but also how these developments really helped usher in the scientific revolution that occurred in Europe later.
Okay, well, thank you very, very much. Really, really interesting. To all the students, I hope you have enjoyed this fantastic lecture. To all I have some guests that are deeply admired of the Islamic world, and I am very happy that they are also here. And Nidhal, thank you very much. Really, thank you.
Thank you so much. Thanks to everybody who sent a note on chat. I was not able to reply, but thanks to all of you. I can see a lot of people sending kind notes. So I want to thank them back orally at least. And I look forward to coming back perhaps next semester or next year. And the very best to you, Diego. Thank you so much for all you're doing, not just for inviting me, but this whole series of this big ideas and history of big ideas is a fantastic series. So I congratulate you and I wish you the best of success.
Thank you very much. I hope can we have a copy of the lecture you presented?
Of course, I'll send it to you.
Fantastic. Salam alaikum.
Welcome. Alaikum salam. Bye bye.
Ok, así terminamos el día de hoy. Muchas gracias a todos. Un fantástico encuentro para los lunes. Que tengan un excelente día. Nos vemos la próxima semana. Adiós. Bye bye.